Imagine gazing up at the night sky, not at a sphere-filled cosmos but at a universe of flat, disc-shaped objects suspended in the vast void. The sun, the moon, the stars, and every distant galaxy, all flat. What kind of universe would this be? Could these flat worlds sustain life as we know it, and what would happen to the laws of physics that currently bind our universe together? Let's dive into this alternate reality and explore the mysteries, marvels, and potential challenges of a universe where every celestial object is a flat plane. Redefining gravity, the pull of a flat world. In our spherical universe, gravity pulls objects toward the center of mass, causing planets, stars, and other massive bodies to form into spheres. But if all celestial objects were flat, gravity would have to operate in a radically different way. Perhaps, in this flat universe, gravity doesn't pull towards a single point but instead acts perpendicularly to each plane's surface, like a force pressing straight down on a table. Imagine standing on a flat planet. Gravity would pull you down in the same way it does on a spherical Earth, but the further you traveled toward the edge, the stranger gravity would feel. Near the edge, gravity might tug you at an angle, making it feel like you're walking up an invisible slope to the planet's border. The landscape would curve upwards, and standing at the very rim might feel like clinging to a mountainside, with gravity dragging you back toward the center. This unique gravitational pull would also mean that mountains, oceans, and the atmosphere itself would be affected. Rivers might only flow toward the center, and towering mountains might struggle to remain stable as the ground beneath them slopes toward the middle. Life on a flat world would be bizarrely asymmetric, with ecosystems thriving near the center but becoming increasingly inhospitable as they approach the edges, where water and atmosphere might thin out or spill over entirely. The sun, moon, and stars, strange, disc-like celestial bodies. Now, imagine looking up to see a flat sun hovering above a flat Earth. For a flat universe to maintain a day-night cycle, the sun might have to travel in a circular path above the Earth, casting light like a spotlight rather than radiating it evenly. Night and day would become localized events, with the sun's light sweeping across regions of the disk rather than rotating around it. Imagine a world where you could see daylight only as far as the light reaches, with darkness looming just beyond the edge of the lighted region. The moon, too, might hover and rotate in a strange, disc-shaped pattern above the Earth, showing us a different face every night or maybe not phasing at all. In fact, moons orbiting flat planets would present huge challenges. A flat moon in a circular orbit would constantly have to tilt to keep its flat side facing Earth, requiring entirely new mechanics of movement that go beyond our current understanding of orbital physics. Stars would also change entirely in appearance and behavior. Instead of being massive, glowing spheres of gas, these stars might appear as glowing disks. If they were flat, their light might not radiate evenly, and they might only be visible from certain angles. Traveling through space, you'd see stars fading and reappearing as their flat surfaces tilt relative to your position. From Earth, constellations could even morph subtly as stars appear to flip or disappear momentarily, depending on their orientation. Galactic disks, universes within universes. Zooming out even further, we could consider what galaxies might look like in this flat cosmos. Galaxies in our real universe already have flat, spiral shapes, but they are still three-dimensional. In this alternate universe, galaxies could be completely flat, like vast, spinning plates. Each galaxy might resemble a glowing, intricate mandala, with stars and planets spread across it like beads on a cosmic disk. But if these galactic disks were truly flat, they might lack the gravitational balance to sustain long-term stability. In a universe where everything is flat, gravitational interactions between galaxies would be more chaotic, as they would essentially be like massive, thin plates sliding past one another. This could result in frequent collisions or interactions that could warp or destabilize entire galaxies, making this flat universe more volatile and prone to cosmic traffic jams. A universe of infinite edges and horizons. One of the most intriguing aspects of a flat universe is the concept of an edge. If celestial objects were flat, they would all have edges, raising countless questions. What lies beyond these edges? Would you fall off a flat planet, or would there be some unknown force or structure beyond it? In this alternate universe, edges might hold secrets, perhaps the remnants of cosmic forces, strange rifts, or even different physical laws. In a flat cosmos, you could imagine explorers attempting to reach these edges, much like ancient seafarers who sought the limits of the Earth. Space travel itself would be far more dangerous and mysterious, as each celestial object's edge might present unique challenges or properties. Passing beyond the edge of a flat galaxy might mean leaving familiar space entirely, venturing into unknown regions where even light behaves differently. The impact on time and space. Time and space, as we know them, rely heavily on the assumption of spherical objects and symmetrical forces. In a flat universe, these concepts might warp or twist in ways we can barely understand. If all matter is distributed in flat planes, the concept of a three-dimensional universe becomes distorted. What happens when two flat universes collide, or if space itself bends or folds? Some theoretical physicists have explored the idea that flat, two-dimensional universes could exist in a multiverse setting, intersecting like the pages of a book. If our flat universe brushed up against another, it might lead to strange phenomena, energies leaking from one universe to another, creating anomalies or strange particles in both planes. Imagine bursts of light or waves of energy spilling into our universe from another flat dimension, igniting superstitions and wonder among inhabitants. The limits of life and consciousness. Finally, what would life be like in a flat universe? Living on a flat Earth in a flat cosmos, intelligent beings might perceive and experience the universe differently. A species on a flat world would likely see the concept of a three-dimensional universe as odd, perhaps even inconceivable. They might develop different philosophies, sciences, and cultural myths centered on their edge-bound reality. Space travel might be unthinkable or take on mythic qualities, with the edges of their world as the final frontier. Additionally, the way living organisms are structured would change, potentially producing life forms adapted to a flatter, more centralized gravitational field. Trees might not grow as tall, animals might be drawn to the middle of the world, and large-scale migration would rarely head towards the edge. Evolution might take entirely new directions under these constraints, with survival and adaptability based on staying near the central, gravity-balanced zones of a flat world. Why our universe isn't flat, a spherical triumph. In reality, a universe of flat celestial bodies isn't just difficult to imagine, it's almost impossible according to our current understanding of physics. Spheres are energetically efficient and stable in the presence of gravity. Planets, stars, and galaxies form into roughly spherical shapes because gravity pulls everything toward a central point, minimizing surface tension. A truly flat celestial body would be unlikely to sustain itself without immense artificial forces holding it in place. A flat universe might be intriguing to consider, and it stretches our imagination, but it would face enormous physical challenges. Our universe, with its rich tapestry of spheres and spirals, is built for stability, longevity, and balance, a stark contrast to the strange, precarious equilibrium of a flat cosmos. So, as captivating as a flat universe might be, the reality of our spherical, structured universe is a masterpiece of cosmic engineering, offering harmony, symmetry, and beauty in ways that a flat universe could never sustain. Ultimately, while a flat universe is an idea that can spark wonder and questions, it is our spherical universe that allows life, evolution, and discovery to flourish in all their extraordinary, three-dimensional glory.